Okay, so we're on chapter 5, the flow of food. So after completing this chapter, you should be able to identify types of contaminants and methods of prevention, explain ways to prevent time-temp abuse, describe how to use and maintain thermometers, and describe how to calibrate a thermometer. Okay. All right, so here's your flow of food, like I just said, on page 98 in your book. All right, the path that your food takes through your operation. So if they ask you, what is the flow of food? This is the definition. You look for that in your choices, right? I said last week, it's all multiple choice. If this is in there, you know it. That's what the answer is, okay? How we keep food safe throughout this path is to prevent cross-contamination and prevent time temperature abuse. Okay, so we're in control of those things. Cross-contamination can occur almost anywhere on the flow of food. And so how do we reduce the risk? We're going to use separate equipment for raw and ready-to-eat food. So in this picture, they have the yellow cutting board. Then they're preparing chicken on it. Do you have to have different colored cutting boards in your kitchen? No. All right. Some places find that it's helpful to have that additional visual. And so they'll invest in the green one for produce, the yellow one for raw poultry, the blue one for seafood, red one for meats. But you don't have to, because second, and even more important, and additionally important, is to clean and sanitize before and after tasks. So we're just going to know through our proper training that we cannot use this board for anything other than processing this chicken. And when it's done, we're going to wash, rinse, and sanitize the board, the knife, and the counter that we're working on, and before we start the next task, okay? And we're gonna prep raw and ready to eat food at different times. So one before the other, okay? If you have a humongous kitchen, maybe you're gonna do it in 2 separate areas of your kitchen, but we're just gonna know there is no way to cross-contaminate, okay? All right, Oh, and then one other thing that they recommend in here, and it is in your book, is to buy pre-prepared food. So, for example, bags of lettuce that have been triple washed, you just dump and use, okay? That's another tactic that you can use, okay? So using separate equipment, cleaning and sanitizing before and after. Remember that before part can be a trick. Especially in questions, because you don't know what's happened before you arrived, or if you walked away and come back for any length of time, right? And then you're going to prep at different times or different locations, or buy pre-prepared food. Okay. All right. Time temp control. I'm sorry. Temperature is being time temperature abused if it is held in the danger zone of 41 degrees to 135 degrees. So anytime that food is being in that danger zone, we consider that time temperature abuse. It's cooked to the wrong internal temperature, which we will talk about. So every type of food that we are cooking has an internal temperature that we have determined scientifically is where the pathogens are least or are most killed off, most safe for us to eat, okay? And it's different for different things. And then that it's cooled or reheated incorrectly. That is an abuse. We talked about that in the article at the beginning of class, that rice was not being either held properly or cooled incorrectly, and those Bacillus cereus flourished. The toxins, the spores it gave off, made people very, very sick, okay? So that's time temperature abuse. That's why we know the temperature danger zone. We want to keep our food below 41 or above 135. Steps that we can use to prevent time temperature abuse. Simple things. We're going to make sure we're monitoring and recording temperatures. So you're going to have food handlers are going to temp things regularly. They're going to use probe thermometers if it's something that can be surface tested. If you are ever shopping in Wegmans, you'll see people running around temping things all the time, and they're keeping records of that. Okay. keeping records in this day and age is your best bet to prevent any kind of trouble coming back on you, because you can say, we've had people, like every couple of hours we've done X, Y, and Z. All right. We're going to make sure we're using the correct tools. So we're going to have lots of different probe thermometers ready. We're going to talk about those in a minute. We're going to make sure people have them, that they are correctly calibrated so that we know that food is not in the danger zone. Okay, and then we're going to understand what our corrective actions are. Okay, for example, if you hold soup on a steam table and the temperature falls below 135, after 2 hours, you might have to reheat it to the correct temperatures or throw it out. Okay, so we have 2 hours to play with. After 2 hours, we have to take corrective action or get rid of it. Okay, and we'll talk about that. All right, so knowing what the corrective actions are is an important thing. All right, so this on your screen, and it's also on page 103 in your book, is known as a bimetallic stemmed thermometer. It is the most common thing you're going to find in a kitchen. They're cheap and cheerful. They're easy to use, but they also fall out of calibration really quickly. Okay, so the thing you need to know about this guy is hard to see in the on the screen here, but right here there's a little dimple. This whole bottom part here is the sensor. Okay, so if I'm just putting this, say I'm doing like chicken cutlets, and I just put this little 1/4 inch of the probe in here, it's still measuring. It's still measuring air temperature. So this whole thing up to the dimple has to get inserted into whatever it is you're temping. Okay. It has easy to read markings up here. So this is in Fahrenheit. It goes in, 20, 40, 60 with that little 10 in between it. Super easy to read. All right. The other thing you need to know is this little nut underneath the bottom is the calibration nut. And there, it often will come with... It comes in this little sheath where you can hold it. Sometimes it has a place where that nut locks, and you can just adjust that little top face of it so that we can calibrate it, okay? And we'll talk about that in a minute, okay? So bimetallic stemmed thermometer. This is it. You're going to know what it is. You're going to see tons of them, all right? But know that dimple is important, and so I always tell people, like if I'm temping a chicken, boneless, skinless chicken breast, I'm not going to temp it this way where only a little bit of that bimetallic stem goes in. I'm going to go in this way. So I hit dead center of the fattest, thickest part, okay? And I'm going to make sure that whole end of that bimetallic stem thermometer goes in there, okay? This monitoring time and temperature continued. We can use things called thermocouples or thermistors. There are different kinds of probe thermometers that are digital, okay? They come with different tips that you can change out. So they are very expensive on the onset, but you can use them for multiple jobs, which is very handy. And if you look on page 104, I don't think they give me this, they show you the different types of probes that you can put on that. Okay, so there's an immersion probe that's what we're doing here. We're immersing it in that water bath. Surface probes check surface temperatures for things like your grill tops, things like that. Penetration probes, things you're going to insert for internal temperatures of food, and then air probes. Air probes are great for checking the temps inside your coolers or inside your ovens. So just know kind of sort of what those different probes are for, and that those are used on a thermocouple, okay? And then the last one is an infrared thermometer. They usually look like a little gun, and you point and shoot, and it bounces off an infrared beam. All right, so they're used for surface temps. So in your book on page 104, do we have one in here? No. Okay, so on page 104, they show you like somebody is accepting a bags of shredded lettuce. They're using that infrared thermometer to take the surface temperature to make sure that it's at the right temperature before you take it in, okay? So just know what those different thermometers and probes do, because they all have different jobs and they are all handy, okay? All right, this is... God, I can't even talk anymore today. This is known as a maximum registering thermometer, and this one actually is a time temperature indicator, but they both, they look similar, okay? But this is called a TTI, time temperature indicator. So this is something that we're gonna, or that shows when food has been time temperature abused during shipment or storage. So this is one of those things that we're going to use maybe if we're having issues of things not being delivered at the proper temperature. It shows us if it's the maximum register, it's going to show us the highest temperature that the product has reached while that little tape has been on it, or the time temperature monitors both the time and the temperature, so how long it's been in there. And one of the times we're going to really worry about that is like if we have a key drop procedure, which we will talk about. Say I have an arrangement with my my supplier that they're going to drop off really early in the morning before anybody's in the building. You have a reputable supplier, somebody you know, they're going to know how to get into your building. They're going to be able to come in and leave product with you, and we'll talk about what they need to do and what you need to do when that happens. But you may want this indicator on it to make sure that we haven't had time temperature abuse. Another story, there was somebody delivering for like a big outfit like Cisco, and the guy was bringing things from their cold storage and doing his deliveries. But when the refrigeration truck is on, it takes energy. So he kept turning off the refrigeration so he could drive faster. And he thought he was being helpful because he could get more, get to his clients earlier. But all the while, the refrigeration was turned off in the back. So people were noticing, especially at the end of his run, that there were things that were not at the proper temperature, okay? So somebody didn't train the driver didn't understand, it was not done maliciously, but it was a mistake. So that time temperature indicator is able to show you that things that you're accepting have not had time temperature abuse while they've been transported to you, okay? All right, how to calibrate your thermometer. Super easy. These bimetallic stem ones need calibrated. They recommend that you do them before you start your shift. And I think it even says, after 4 hours, just because you can knock it against something. If it's going from super cold to super hot and back, it can get out of calibration. So they want you to calibrate these frequently. The digital ones, they don't fall out of calibration, and it's really simple to test them. All right, so the two ways that we recommend calibration is either the boiling point method, but you have to know what is the temperature of boiling water. Thank you, 212. Or the ice point method, which is what they're demonstrating here, which means we're going to fill up a container. Here they have a glass. You could use a quart container. Lots of ice and water. It can't just be ice on its own because there's lots of air in there, right? We're going to make what we call an ice slurry. We're going to sink that sucker in there. We're going to wait till it finishes registering, and it should read what is freezing. 32, okay? So, as a common sense human being, would you rather sink your thermometer into ice water or hold it over boiling water? What would you rather do? Ice. I'm not going to stand there with my hand over a hot pan, but those are two definite temperatures. We know, 212, 32. We know. So that's the way you're going to calibrate. So generally, the ice point method is just going to be the easiest way to do it, and it is what most people do, okay? All right. So just know we have to calibrate these bimetallic stems frequently, okay? Let's see. I just want to make sure I didn't miss anything on that. No. Okay. You have to wash, rinse, sanitize, and air dry your thermometers. Okay, so your thermometers have to be cleaned in between uses. Glass thermometers can only be used if they are included or if they are enclosed in shatterproof casing. So in the lab over at Near Kitchen, we have them when we use the fryer. People who do candies will use a glass thermometer, but they have to be in shatterproof casing, obviously, so that we do not contaminate whatever it is that we're cooking with glass, right? Which would be what kind of contaminant? Physical contaminant. Thank you. Okay. And then just know that your thermometer needs to be within plus or minus 2 degrees of accuracy. Okay. On the digital, it's much easier to read that than on the face of these bimetallic stems, but just file away plus or minus 2 degrees, because that sometimes will show up as, and if you know it, it's a gimme question. Okay. All right. So they want you to calibrate after they've been bumped or dropped, after they've been exposed to extreme temp changes, before your deliveries arrive, because we're going to use these to approve things that are coming in, or before your shift. Okay. That is one of those things that a lot of people neglect to do. All right. It's a thermometer. It should just work. But now you know it can become, it can go out of calibration so easily. As the manager, it's your job to put that in your protocol. This is what I want you to do. Okay? All right. Let us, we're going to, when we are checking the temperature of food, we're going to make sure to insert the thermometer or stem or probe into the thickest part of food. Again, I'm going to go back to that boneless, skinless chicken breast. The skinny end, of course, is going to get cooked through real fast. It's the fat end, especially if you don't make it into a cutlet and you've got a big, juicy one. Okay? Thickest part is where the probe is going to be. All right. We're going to take more than one reading in different spots. If it's something, especially if it's a bigger piece, we're going to go in here. We're going to go in here, right? We're going to make sure we're checking things because juices circulate. Muscles are of different densities. There are different things going on in there. So we just want to make sure we hit the minimum cooking temperature for whatever it is that we're serving. And then we're going to wait for the reading to steady. Okay. So just stick it in there, hang out. Usually like these digital ones are pretty darn quick. The bimetallics can take a few seconds, but generally they're pretty quick. Okay. All right. So using one set of cutting boards for raw poultry and another set of cutting boards for ready to eat food reduces the risk of cross-contamination. Okay. Remember cross-contamination. What's cross-contact? What do we associate that with? Allergens. Thank you. Okay. Cross-contamination is what we talk about the most, but if you see cross-contact, that is a different thing, and we are talking about allergens. Question 2, pathogens are likely to grow well in a meat stew that is below freezing, at refrigeration temperatures between 41 and 135, or cooked to the correct internal temperature. Temperature danger zone, right? We're going to hang out at 41 to 35, that's where that bacteria grows the fastest. Food must be thrown out after remaining in the temperature danger zone for 1 hour, 2 hours, 3 hours, or 4 hours. It's 2 hours. You have 2 hours to either throw it out or to make an adjustment to make it safer, and we'll talk about that a little bit later, okay? In general, if you remember 4 hours, oh, I'm sorry, here they say 4 hours. Hang tight. What was the question? Oh, yes. You've got 2 hours to make adjustments, and they did say on the steam table 2 hours. So this is wrong. This is wrong. It should be 2 hours. Which thermocouple probe should be used to check the temperature of a pork roast? Should we use the air, just taking the surface temperature, immersion, or penetration? Right. It's the penetration, right? We want to use the probe that goes inserted into that meat. When using the ice point technique to calibrate a thermometer, what temperature should the thermometer be adjusted to? What's our ice point? Is it 0, 32, 41, or 212? Right, 32 degrees Fahrenheit. If we're working Celsius, it's 0, but in our world where we're working Fahrenheit, it's 32. Okay. How long does it take a bimetallic stem thermometer to steady when it's inserted in the food? I did not mention that, but do they have it here? It says to wait 30 seconds, okay, until it stops. And here they have 15. So this must have been an update that I did not catch.
It says it in the book right here.
Where?
It says it on page 108.
Oh, it does say 15 seconds. Okay. Well, see, now on, oh, that's because it's the calibration. I'm sorry, guys. Like I said, they gave me a whole sheet of updates, and I always feel like I'm missing something. And after 10 years of teaching this, things do change. And it's so stupid. It's like a little thing. Okay, so it is 15 seconds. Okay, we're going to wait for 15 seconds, which is an example of corrective action for time temperature abuse. So we're going to check and record temperature of hot held food every hour. Is that a corrective action? A manager trains food handlers to calibrate different thermometers. A stock pot of soup has been left on a prep table overnight, so a food handler throws it away. Or a restaurant requires suppliers to place temperature recording devices in their trucks. So which one is a corrective action?
C.
What do you think? C?
C.
Okay, it's a corrective action. So here, the food handler checking and recording temperature is preventative. A manager training food handlers to calibrate is preventative. And D, a restaurant requires suppliers to use the temp recording devices in their trucks. Preventatives, right? So remember, here it says a corrective action. We're going to fix the problem. Well, if that soup's been out on the table overnight, you cannot serve that. You cannot eat it, okay? It is a soup of bacteria by that point. So the corrective action is we're going to throw it away, all right? All right, people. I'm sorry for my brain cramps today, but so now you know that's step 1 that we're going to talk about. So just familiarize yourself with those different kinds of probes. Know the temp danger zone and the pathogen growth. And next week, we'll do 6, 7, and hopefully 8. All right? Have a good week. Thank you for coming. All right.